Lots of notes today. Okay. So, gotta do some notes. Very important notes today. It's gonna clean up some confusion, hopefully, for you about reference angles, or create some confusion, and then you're gonna ask questions. Okay. And then we got 2 worksheets yesterday. You'll get a 3rd worksheet today to go along with the 3 worksheets from last week. So that brings you up to a total of 6 worksheets. Plus then next Tuesday you'll get another worksheet. And it's just all about worksheets. Schmeling just wants you to have more and more and more work to do. He just walked by, so I was wondering if he was going to come in and refute that statement. Okay? Okay. As of right now, still plan on the test on the 30th of November, which is the Thursday after break. All right, here we go. So, first part is kind of, I'll be honest with you, you can write down what you want to write down on this. A lot of this is just getting us all with the same vocab and ready to go. Okay? So, an angle has 3 parts to it. The first part that an angle has is an angle has something that is called an initial side, where the angle starts. Okay? So that's our initial side. That's a ray, so it has an end point on one side, and it goes on forever and ever and ever in one direction. Okay? That end point that we have of that initial side ray, we call the vertex. Okay? Then, to actually form an angle, you then rotate the initial side around or about the vertex, and then you stop it at something that is called the terminal side. So we would rotate this initial side through and up, and we would stop it at that side. Okay? The measure of an angle can be given in degrees or in radians, okay? But the measure of an angle is the amount of rotation from the initial side to the terminal side. Okay. We can measure that in 2 different ways. We can get a positive measurement by going counterclockwise. So that's kind of like unit circle rotation. Positive angles, we're going in the counterclockwise direction. We could get a negative angle or a negative measurement if we went in the clockwise rotational direction. To make it easy on all of us so that we're all not thinking differently and putting things in different areas and all that stuff, we have the standard position so that we all have I don't want to say all conform to the same thing, but then we all have the same thing so that if I'm telling you this angle is in standard position, you know that, okay? There's a couple of conditions that go along with being in standard position. First off, the vertex of the angle is at the origin. So we would rotate around the origin, rotate about the origin is the proper mathematical charge. The second classification, or the second condition, I should say, is that our initial side is on the positive x-axis. Okay. So if you have your standard XY crosshair, okay, your vertex would be at the origin. Your initial side would be along the positive x-axis, and then your terminal side would be somewhere out there. If that's the case, then we start here, and we go through there to get our positive measurement. Going the other way would give us our negative. Okay. All right. Now, with that being said, we also have something out there called coterminal angles. Because if an angle is in standard position, then any angle that shares the terminal side would be called coterminal. I have to finish my sentence. So jazzed up. I don't know. You should get so excited about something. Yeah. Okay. So, let's say, I don't know. Give me an angle then. 23 degrees. Love it. Okay? Okay? So a 23-degree angle would be like right there. Would you agree? Yeah. Okay? Right? And that would be measured from here to there. Yes? Okay? Give me a coterminal angle with 23 degrees. That would not be coterminal with 23 degrees. Negative 337? Negative 337 degrees would be coterminal with that, because that would be going that way around. Coterminal. Give me another one that's coterminal with it. No? We'll stay in degrees. Or are those the only two angles that are coterminal? No? I personally think that 383 degrees is also coterminal 53 degrees. Because right there is 383 degrees. What would another one be? Negative 600 what? 97? Because that would be that one. See how we're getting those so quickly? What isn't the number? Negative 697? Not using numbers. How can we find coterminal angles like quickly? Add 360 if we want to be positive, and subtract 360 if we want to be negative. What if we were dealing in radians? Add or subtract how many? 2 pi's. Okay? Right? So we add or subtract 2 pi's. It's an obviosity thing. You learned in the obviosities that if you go around a circle once, you're at a spot. If you go, so if you picked an angle, you're there. If you go around the whole circle, you're at the same spot. If you go around twice, you're at the same spot. Okay? Either direction. Okay? This is an obviosity thing for coterminals. Okay? So with that being said, what I would like you to do is I would like you to draw in the angle and then give me one coterminal positive and one coterminal negative angle for each of those. Go for alpha and theta. I got negative 150 degrees down there. So you would just need one off of this list. 210, 570, 930, 1290. So one of those 4 off of the list would suffice. Okay? Negative list would be negative 510, negative 870, negative 1230, and negative 1590. You again will only need one of those off of that list. Okay. Questions on that one? Okay. Over here, 2 pi over 3. Is there. My positive list would be 8 pi over 3, 14 pi over 3, 20 pi over 3. What am I adding here, truthfully? What am I adding? 6 pi over 3. Yep, because that is then 2 pi. Because then it's in common denominator form already. Okay? Subtracting 2 pi each time, so then this would be negative 4 pi over 3, negative 10 pi over 3, and negative 16 pi over 3. Love it. Yeah? Good stuff. Yeah? So let's get into reference angles now. Now that we know all about angles and their coterminalness and their all that fun stuff, let's get into them right now. I would like us to find theta if the terminal side of theta goes through the point -3, comma, -2. So first off, what we have to determine, I'll wait. Finish your conversation. I'll wait. And this is just kind of the most important part of the day. No, really, finish your conversation. Because then I know it's done. First thing that we have to determine is where -3, -2 is. Where is it? Quadrant 3, right? Okay. So we would go left 3 and down 2. Right? I want to know that angle. Well, that's here, right? That's theta. So what am I going to use? Tangent. Okay. So the tangent of theta is going to be the opposite over the adjacent. So the tangent of theta is what? -2 over -3. How am I going to find theta? We're going to use inverse tangent. So we're going to need a calculator. Yep. Okay. So we're going to go, theta here is the inverse tangent of, can I just make it 2/3? Yeah. Okay. Anybody? So is my theta 33.69 degrees? Yeah, right? Yeah? Yeah, it is, right? Because that's what we found, that's what we got. Yeah. Yeah, why are you saying no? Okay, well, sorry. Is my theta approximately 33.69 degrees?
Have to go all the way to the positive x.
You tell me.
No, that would just be the.
Because do you agree with this, ma'am? I mean, I thought we did it right.
The terminal side of theta, so you're talking about, so you would want it to be the whole thing.
Okay.
Yeah, because you have to go to
Because it is.
your initial side.
What's wrong? Okay, so first off, let's go back to my very first question about this problem. Where is this angle?
It's the whole
Quadrant 3. Talk to me about all of the angles that live in quadrant 3. They're what? They're between what? They're bigger than 180 and smaller than 270. Ruh-roh!
Yeah. You just have to
Right?
put in the tangent.
Right? What? Right? So, I mean, our math is good, but the problem is we found what is called the reference angle. Okay? Now, the reference angle is the acute angle, so that means it's between 0 and 90, which is what we found, okay? Right? Formed by the terminal side of theta and the horizontal axis, which means the x-axis. Okay? Now, the most important thing from this slide is that we call our reference angle theta prime, and theta prime is always off of the horizontal. theta prime always has one of its sides as the horizontal x-axis. Okay? Always. Alright? That's so important that I think it is worthy of 8 stars. And 2 smiley faces. Pretty important. Okay. Now, this chart that we're about to make right down here is kind of important. Okay? So we're going to draw ourselves a quadrant system.
Like big.
Kind of big. Because we're gonna fill in some stuff here now with it. Okay? So I'm gonna start in quadrant number 1, which is up here. Reference angles, Mrs. Hill. What are you doing? Put the cheaters on there, old lady.
Oh, you do it different stuff.
Yeah, I put it in there actually. Here, you can take that. Okay. So in quadrant 1, because our reference angle is acute, what are all of the angles in quadrant 1? They're already acute, so theta is the reference angle in quadrant number 1. Okay?
Did you tell them this is like a top 5 lesson in here?
She knows. I said
We do
super
this
important.
over and over
Yes.
and over and over and over.
Yes. Yes. Then let's slide over to quadrant 2. Now in quadrant 2, our theta is going to be 180 degrees minus our reference angle. Or, if we're dealing with radians, pi minus our reference angle. Because we're just flat out mean, and sometimes we'll say degrees, and sometimes we'll say radians. You're not stealing my notes, are you?
Wait, I thought you were giving them to me.
Well, I was just showing you where we were. Good gosh, man.
I got my own notes here.
These are just in color. The touchdown. How to do that.
Color them?
Color them. Quadrant 3 is down here. So now my theta is going to be 180 degrees plus my reference angle, or pi plus my reference angle. We just did that one that was in quadrant 3. So really here, our theta should be 180 degrees plus 33.69. So our actual theta here, which would be in quadrant 3 then, would be, what's that, 213.69? All right. And then we've got quadrant 4. In quadrant 4, our actual theta is going to be 360 degrees minus our reference angle, or 2 pi minus the reference. Okay? All right. So, what I want you to do now is I would like you to draw out these 3 angles and then find me their reference angles. Okay? Alright? So drawing out all three angles and then finding me their reference angles. So for number one, I got a theta prime of 55 degrees. Yes? For number two, I got a reference angle of 40 degrees. And for number three, I got a reference angle of 50 degrees. Yes? Okay? Now, what I want you to do is I want you to find a shoulder partner or a triple, I don't care how much, but you need at least two. Okay? Okay? Both of you need a calculator. Okay? Right? So what you need to do is one of your partners, raise your hand right now. One of the partners, raise your hand. You are theta. Okay? Right? Partner without your hand raised, you are theta prime. Okay? Right? Right? So what I want you to do is I want you to find the sine, the cosine, and the tangent of each of your angles. So if you are theta, you're finding me sine, cosine, and tangent of your theta. 125, 220, or 310. If you are the non-theta, if you're the theta prime person, you're finding me sine, cosine, and tangent of the reference angle. Yes, ma'am. It is in degrees. I want the decimal. Yeah. All right, so in the first one, did you find any of them to be the same?
Yes.
Which one is the same in the first one? Sine is the same in the first one? So sine of theta equals the sine of theta prime. Did we all agree with that? Okay. What about the other two? But opposite SIGNs?
Yeah.
Yes. Okay. So then this would be equal to negative, like that? Yep. Okay, I would concur with that. In number two, did we find any of them to be equal? Tangent? What about the other two?
They're opposite.
They're opposites. What about the last one? Cosine. The other two are opposites. Talk to me. Why? So this is in? It's in the second quadrant, and my reference angle is always in the, because it's an acute angle, so it would be in the first quadrant. Okay? So sine is equal if we're at the same, positive, same angle type things in 1 and 2. So that's why sine is positive, the other ones are negative. In here, tangent is equal across in quadrants 1 and 3. So that's why tangent was equal there. And here in quadrants 1 and 4, cosine is the same. We learned that on the opposites also. Okay? All right, here we go. Theta is in standard position. Refresh my memory from earlier in class. Standard position means going out that way. Okay. Vertex is at the origin. Okay. All right. Fantastic. So let's start with the old crosshairs. Where would the point, which quadrant I should say, would the point -5, 12 be in? Quadrant number 2. Okay. So that would probably be much more up here, right? Somewhere up like there. Okay. So then that makes this be 12. That makes this be 5, correct? No. It's 5 and 12, right? You're 2 steps ahead of us. Tap the brakes now. What did you say about the -5?
It would be -5, but that doesn't matter.
Doesn't really matter. I like to put it in there, so I'm glad that you like to put it in there. So let's put it in there. You'll see why in a minute. Okay? All right? With me? Now, we need to find the sine, the cosine, the tangent, and actual theta. Okay? So actual theta would be right here. What would this one be? That's going to be theta prime right there. Okay? So, what do I need in order to find the sine? Need the hypotenuse of that triangle, that little like green and blue triangle that we made, right? Okay? So that's where, is that where you were meaning 13 comes in? Yeah. Okay? So this side length right here is 13. If you don't know it, it's the Pythagorean theorem. Oops, I put 13. That should be 12. Okay? Alright? So, then of my theta, what would the sine of my theta be? Sine of my theta would be 12 over 13? Do we agree? We're in quadrant 2. Is sine positive in quadrant 2?
Yeah.
Yes. So that would be 12 over 13. The cosine of my angle. That would be -5 over 13. Is cosine negative in quadrant number 2? Yes. Which is why I like to put my negative sign right on my graph or on my picture. Okay? Because then that reminds me that it's got to be negative also. Okay?
Is it supposed to be sine theta?
Nope. I want sine of theta.
So how's it not sine theta?
Because we just found that if we're in quadrant 2, that the sine of theta is the same as the sine of theta prime. That's one. Okay? What would the tangent of theta be?
-12 over 5.
-12 over 5. Is tangent negative in quadrant number 2?
Yes.
Yes. Okay. Now, we need to find actual theta. Okay? So, in order to find actual theta,
Why don't we have the time?
huh? So to find actual theta, so I can finish my sentence, to find actual theta, I am going to break out this little triangle that we just made. And that triangle had 12 there, it had 5 there, and it had 13 there, and theta prime was right there. I have to find the reference angle in order to find actual angle. Okay? Alright? So how am I going to find reference angle there? I'm actually going to go so far as to say, let's get rid of that. So we can use the tangent. Okay? So the tangent of theta prime is going to be 12/5. Agree? Which means theta prime is going to be inverse tangent
Because we don't care about that.
of 12/5. D, what was your question?
Why is it not negative?
Because in an actual triangle, all of the sides have to be positive. With me? That's and to be honest with you, that's the reason. You know, because now we're not on the we took this triangle off of the grid and made it an actual triangle, so now our sides have to be positive. Yep. Okay? Alright? So what do we got? (67.38 degrees. Yeah. Okay. But that's theta prime. Which quadrant am I in? I'm in quadrant number 2, which says that actual theta is 180 degrees minus my reference angle, which is 0.62. Chris, I saw yours first.
Okay, so like if it's asking for the final answer on the test, like the actual theta, will you want to keep it in tan inverse 12/5 plus 180 before like rounding it out? You know what I mean?
Yes. Yeah. I only round at the end.
Yes.
Yep. Yep. Mhm. Or what you could do on your calculator is after you find tangent, leave it on there,
Yeah.
180 minus answer.
Mhm.
Yep. Or 180 plus answer, or 360 minus answer. Yes. That's great. But guess what? No, we're going to use tangent. You'll see why in a minute. Yep. I promise. Yep. He found inverse cosine. You could have found inverse sine too, because we had found all three sides. We could do that also. But you'll see why in a minute. Why we stick to just tangent. Okay? Okay? So, before we do this one, I'll just jump right into the in generalness of it. Okay? So, in general, if theta is through a point, okay? So if we're going through this specific point, okay, then r is going to be the square root of x squared plus y squared. This is the hypotenuse of the triangle that we would make. Okay? It's Pythagorean theorem. Okay? We squared the x values, we squared the y values, we added them together with the square root. Okay? Right? If that's the case, then the sine of your actual theta is y over r. The cosine of your actual theta is x over r. Tangent of actual theta would be y over x. These then would just be their reciprocals. And with all of those, your SIGNs, your positivities, if you will, come into play. Okay? So with all of those, if it's negative, like we had -5, -5, 12, the -5 came into play for an X value. Okay? On top of that, here's where this is important now. Okay? So here we do, to find our reference angle, it is just the inverse tangent of y over x with one extra condition. And that extra condition is we drop all negative signs. Okay? Because D, that brings it back into yours, where now we're on the triangle, so that's why we made them positive. Okay? Right? So that finds us our reference angle. Gotta drop the negatives. Okay? That gets us an acute angle, that puts us in there, and then from there, we have, now I gotta go back, way back to it. We have, oh, maybe not, maybe, oh, have to break it down, I didn't go, went too far. We have all of these then too, okay? So because we have our reference angle, then we have to refer back to this chart, all right? So with that being said, what I would like you to do now is, from here, find me the sine, the cosine, the tangent, and the actual theta of this point. Should have gotten the hypotenuse of your triangle of 5. Okay? So if that's the case, then the sine of my actual theta is y value, that's -4 over 5. The cosine of my actual value is x value, -3 over 5. And the tangent of my actual theta is +4/3, because it's -4 divided by -3, which reduces to positive. Yes? On all of that. Okay? Then we can say that my reference angle is equal to the inverse tangent of 4/3, because I dropped all of my negative signs. Okay? And that should give me a reference angle of approximately 53.13 degrees. Yes? But what quadrant am I in? I'm in quadrant 3. So because I am in quadrant 3, then my actual theta is 180 degrees plus my reference angle. So my actual theta is 233.13 degrees. Agree? We will come back to this so many times this year. Okay? So many times. I do have a worksheet for you now, and my lovely and talented assistants up here are going to be passing them out to everybody in the room. Okay? This brings you up to now 6 worksheets. You will get the 7th on Tuesday.